You may want to take notes on this as well. Even though I'm just doing this on the computer, you could still do a little rough sketch of this. All right. So we talked about the family of graphs, right? We did the x squared and the square root and all that kind of stuff. Is that correct? That's what we did yesterday. Right. And we did do a little bit with the greatest integer function, but I can't remember if we put a number out in front of it. Remember how we put a number out in front that either makes it skinnier or wider, right? Expands it or shrinks it. I think the book uses that word, expands or compress. That's the word they use, not shrink. You compress it or you expand it, right? So instead of making it fatter and skinnier, right, it's not really a very good math term, all right? So we say we either expand it or we compress it, all right? Those are the words that they use. So let's see what it does to this. So first thing we're going to do is put in just the parent function. When I say the parent function, it just means the one without stretching it, right, or shrinking it, or moving it left and right, up and down, flipping it, and all that kind of stuff. Just the regular, normal, everyday function. So the greatest integer function, what did I say, floor? Isn't that right? X. There it is. All right, so that should look familiar. Agreed?
Yeah.
Just make it so I see just 1, 2, 3. There we go. All right, so there it goes. That's what it looks like. I'm not going to explain how we got that. I'll tell you what, I think I can do this. I think I right click. No, not right click it. Oh, not do that. Hold it. Yeah, there we go. And I can make this, because that red kind of blends in a little bit. Maybe make it even a little thicker. There we go. That looks better. I just discovered that yesterday. All right, so there you go. Now you can see a little bit better. All right. So what's going to happen if we put a +1 here? Let's just go through those before we expand it or compress it. So what if I put a +1 after that parentheses? What's it going to do to this? It's going to move it up 1. It's going to move it up 1. Remember, it moves it left or right if it's inside of the function. Okay, so if it was inside that parentheses, then it would move it left or right. All right, but if it's inside the function, or it's outside the function, sorry, then it moves it what? Up or down. So if I put plus, we'll just do 1. +1, there it goes. Or I'll tell you what, just so we can see it a little bit better, let's go a half. All right, see what it just did? So the red one was the parent function. If by putting +0.5 or +0.5, all it did was just take everything and it just shifted it up 1. Everybody good with that? All right, and let's just see what it does if we put a minus right there. See what it did? It took that one and it just shifted it down. Yes? Yeah. Okay. Let's see, what else could we do with it? Let's get rid of that. Let's just make it the original one. And let's move it left or right. What are we going to do if we move it left or right? Put it inside the parentheses, right? So what would I put? If I want to move it to the right one place, -1. Boom, there it goes. See the blue one? Yeah? So the blue one, okay, is to the right. So what if I put a +1 right there? It would just move it to the left. You getting it now, right? Yeah. I mean, you got it yesterday, I hope. Let's do this. Let's put a number out in front of it. What do you think that's going to do? Let's put a 2 in front of it. Let's put a 2. Boom. So the blue one, well, actually, let's do like 2.5 so it doesn't cover this one up. Because this one right here, do you see that? That's actually a red and a blue one together. All right, so I don't want that. So let's make it like 2.5. Did that work? It still didn't work. Hold on, let me see. Oh, there we go. Oh, I see why. Let's just do the 2 now. Let's do a 3. Well, I tell you what, let's do this. Let's do the first one as a 2. And then we'll do another one. And we'll make that one a 3. Just to see it. Okay, do you see what's happening here? Do you see that? So there's the original one. It just goes a nice straight line. It's actually kind of like if I went wide enough, it starts looking just like straight lines, doesn't it? So it's kind of changing the what of it? The slope of it, it looks like, doesn't it? Isn't that kind of like just changing the slope? Yeah? All right. Yeah. Now, if you zoom up, obviously they're little steps, little stair steps. And what else is it doing? Stretching it out, isn't it? Because look, from one step to the other, how far is it from one step to the other? Just one. That's your parent function. What is it for the blue one, where it's 2? You go up what? 2. Everybody see that? All right. What happens on the green one? You put a 3 in there. It goes up 1, 2, 3, and over. Everybody got it? Goes up 3 and over. Up 3 and over. All right. So that's kind of interesting, isn't it? To see that. I mean, that'd be a pain in the butt to have to graph that by hand every single time, right? So it's nice to be able to just stick it into the graphing calculator, in this case, this program, to see what it really does. What about putting a negative in there? What's a negative going to do? Tell you what, let's just get rid of this and get rid of this. We'll copy this one, put it here. What if I put a negative out in front, right there? Watch what it does. Boom. Where'd it go? There it is. See that? So zoom up a little bit, right? Instead of going up like this, we'll call this like our starting place, our origin right there. Look, instead of going up, what's it doing? It's just going down. All right? So that's what that negative does right there. What if I stuck a negative in with the x? Let's see what it does. Negative. Boom. So do the same thing? I don't know. Let's do this. Let's put the negative out in front again. Now, what did it do? It just shifted it. I don't know. It's hard to tell what it did. All right, so the red one's the original one. This is a negative out in front. So instead of I don't know, what would you say? So this is going up like this. It's going down like this. So there's 1. That goes from 1 to 2. Oh, I see what it's doing. Look. See this one right here? Okay, that negative there is this one right here. You see that? This one right here, the negative, since it's in the negative, right, it's at -1, it goes to +1. All right? And then, see that -2? It goes up to +2. This one was at +1, it goes to -1. This is at +2, that one goes to -2. So that's what's happening when you put it in there. I'm sorry, it's this one right here, the negative's out in front. Okay? And then, I'll do that, do this one. It's kind of doing the same thing, isn't it? Looks pretty much the same. Put them both on there. I don't know. I'm a little confused on this one myself, on what that negative's doing and what that negative's doing. I think this negative right here is just flipping it across the x-axis. This negative inside here, that's the one that's, I don't know. Let me see what it's doing. Guys, stop. Just trying to figure this out. Probably should have had it figured out before I put it up here, shouldn't I? Yep. Well, let's just start with the original one. And let's put the one in that's in the book. All right, so this is example 3A in the book. So we've already seen this, but we'll see it again. Okay, I'll tell you what, let's just do this. Put the 2 out in front. All right. Why are they both red? I think I can change the color of it. Make that one green. All right. So we got the green one. I really don't understand why they use the word floor, but I Googled it, and it's like, how do you do a greatest integer function with this Desmos thing? And they said use the word floor, so that's why I put it in there. Obviously, you're not going to do that. What does yours look like? It looks like a double bracket kind of a thing, right? So you're not going to put floor. I just did that for this program to understand it, but you're going to put that double bracket thing, all right? Let's do this. Let's run this. All right, so that's negative 1, 1, right? And then right here, so this is a closed circle right here, and then this would be an open circle right there, right? And then it jumps up. It's closed here, open here. Oh, I'm sorry. I should be looking at the red. The red's the one that's different. Oh, no. Okay, let's go to the end of this. Yeah, so that's open, and then it pops up to there. I think some of these are covered up. That's probably why. Let's do that. Oh, yeah, okay, I see what it's doing. Stupid me. I was thinking we're still going negative. But this is just having that 2 out in front. What does that 2 out in front do? Instead of going up 1 every step, you're just like skipping a step, right? You're going up another one. Yeah, we've already shown that one. So that's what example 3A is doing, all right? So just realizing, what does it do at a greatest integer function? It just stretches it out. What if it was less than 2? What do you think it's going to do? Let's put the original one there. Let's go like a half. See what it did? Instead of going up 1 full step, what's it do? It only goes up half a step. Does that make sense? If I put a half in front of it, so if I put 2, just going up 2. If I put a 3 in front of it, it just goes up 3, right? And then over 1. If I put a half, it just does what? It just goes up a half and then over 1. You see it? So the green one is the half one. See, it just goes up to half, goes over 1, goes up to another half, goes over 1, goes up another half, goes over 1, and continues that same pattern. All right? Here's a real crazy one. So let's do that so we don't get confused. Let's put that. And this is part B. So it's negative 0.5. And then you got a minus 4 on the end. All right, so let's see what that looks like. Well, what does that negative do? It makes it go down instead of going up. Everybody see that? That's what that negative does. The 0.5 means you just have a half a step in between each one. And the minus 4 means what? You're just starting at negative 4. So it's kind of like, let's do this. Let's make this negative 0.5, but not do anything on the end here. Do you see that? The blue one looks just like the green one, except what? What do we do? We just shifted everything down 4. Everybody see that? All right, so that's what's going on right there. And again, the negative, because it's going down, it's like a negative slope. If I expanded this out like this, it would almost look like a line. All right, I just made one thicker than the other one, but that's kind of what's going on there. And kind of has a y-intercept at negative 4, right? That's kind of what that's acting like. You see what is going on? Now, these are definitely the harder ones. This greatest integer function, it's really difficult to kind of get your head around it. So that's a little tough. Let's do a couple other ones. The next one is just a parabola. We already talked about it, but let's do it again because we're going to do a little take on the parabola. The next two, after this one, the next two, B and C, are going to look kind of different. So let's do this. This is x minus 2, and it's squared. So let's put a squared right there, and then minus 3. So this is something we talked about yesterday that should be fairly familiar to you, I hope. Does that look familiar to you from yesterday? Yeah, it should be. This is a parabola. It's an x squared. So let's put the actual parent function in there. What would the parent function be? Y equals what? Just x squared, right? Okay. So there's the parent function. Let's move this on top, right? So there's your normal, everyday y equals x squared. That's a parabola. And then what did we do to it? Well, we moved it, what? What is that, minus 2? Moved it to the what? Right. To the right. And then the minus 3 does what? Moves it down. So that point right there, see, 2, negative 3, if you were to graph this, now you don't have to be like super exact when you graph it. A lot of these just say sketch the graph. If they say sketch the graph, right, you just want a general look. It doesn't have to like be perfect. Okay, just generally, if I asked you to sketch this graph, you should look at it and say, well, it's this squared, so it's a parabola. It means we just shift it to the right, we shift it down. So if we went to the right 2, we go down 3. Now, how do I find the other points, though? Now, here's what you want to do. If you're doing this on paper, here's what you would do. You know you're starting here, and I don't have that other program where I could write, and I don't think I could write on this, but watch this. If that's my origin, I'll tell you what, let's do this. This will be good. Watch. There's my origin right there, okay? How do I know like how far to spread this thing out? Okay, well, I put in a 1 in for the x. If I put a 1 in for the x,
I apologize for the interruption. I was just feeling it here as we come to 2:30, and the fact is that we have the big game, probably the biggest game of the year. This is the Super Bowl of Super Bowls. As we go and we get to thrash that school, well, I would say up north, but I want to say nasty things because God loves them, I guess, too. So that school called Caravel, we get an opportunity to get a chance to thrash them, beat them, like they stole something. That's how much we want to beat them. So I'm looking forward to the opportunity of our awesome boys going forth and just putting out 110% effort to, number one, honor God. Number 2 is to show school how great Red Lion is in the community. And lastly, it's just so we can put some W next to that name called Caravel that no one in their great mind would like. So I'm asking you all to come to the game, wear your camo gear, and let's go and cheer.
I thought we were wearing red.
Tomorrow at 6 p.m.
Changed it?
You all have a great day. Excuse me, I was just corrected because you're both time. 5:45. The game will start.
So it's 6:30. 6:30 to 5:45. And then it's red.
We can't make these last minute decisions. Okay, let's do this. Here we go. So watch. If I wanted to figure out how to graph this, you kidding me?
I was just corrected. It is camo gear, not. It is red out. Red, not camo.
I'm glad they can't see my face on YouTube.
We want to beat them.
All right. Okay, here we go. Let's try this one more time. Look, if you wanted to graph this, listen, everybody look here. If you wanted to graph this by hand, all right, and you just put a little X and Y axis on your paper, you know it's going to look like a parabola. But how far do you stretch it out? Okay, this is the easiest way to do it, right? Basically 2 points. 3. You're going to start at the origin, right? 0, 0. right? So if you put a 1 in for x, what is y then? Well, it's 1 squared. What's 1 squared? It's 1. So you 1, 1. So that's your point right there. Everybody see that point? Where's the next one over? If you put a 2 in, we talked about this yesterday. If you put a 2 in for x, then it's right here. See, 2 and what? 4. If I could hit it. Right there. Oh, anyway, you saw it. It flat. There it goes. 2, 4. There it is. 2, 4. Everybody see it? And really, that's enough. All right? So watch. When you move it down like this, here, let's get rid of that one. Let's go to this one. Look what we do. We know where the, quote, origin is going to be. It's not at 0, 0 this time. Where is it? It's at 2, what? -3. All right, so you know you're going to start right there at 2, -3. So watch this. If I go over 1, I go up what? If I go over 1, I go up 1, right? Because if I, on this parent one, right? If I went over 1, put a 1 in for the x, what's 1 squared? It's 1. Now, if you wanted to, you could put that point in. What is that point? 3, -3. So you could put a 3 in there, but that's too much work, all right? It's a lot easier looking at it saying, okay, I know where I'm starting, so where do I put my next point? Well, I just go over 1 and I go up 1. Put a point, okay? How do I find the next one? Well, I go over 2 and I go up what? 1, 2, 3, what? 4, right there. And then the other side is exactly the same. The other side is just a mirror image, all right? So if I went over 1, up 1, here, if I went to the right 1, up 1, what do I do here? I go to the left 1 and then I go what? Up 1. Then I go to the left 2 and I go up how many? 1, 2, 3, 4. And that's enough points. Put those points, draw your little curve, and that's a good sketch. You understand what I'm doing? Okay, you don't have to put in every little single point. Just have a general idea what the parent function looks like, where you're starting, all right, and then how far over, how far up. So when it's x squared, you go over 1, up 1. Go over 2, up 4. If I went over 3, if I wanted to, I would have to go up how many? Is anybody paying attention to me? If I go over 3, how far would I go up? I heard it. 9. Why? Because it's a squared function, right? Because I'm squaring it. So if I go over 1, why do I go up 1? Because 1 squared is 1. If I go over 2, I go up how much? 4. Why? Because 2 squared is 4. Okay, follow along. If I go over 3, then I go up how much? 9. Where would that be? 1, 2, 3, 4, 5, 6, 7, 8, 9. Look, right there. See that point? Now, you don't have to go that far, okay, on there. All right? Just do the points that are close by, just so you have a general idea what your curve's going to look like. Does that make any sense?
Yeah.
I should be writing this out, but I'm just going to use this. All right. So that was actually an easy one. All right. This one is a little bit tougher. So let's see what it looks like. So it's y equals, this time we're going to combine an absolute value with a squared function. I don't think I've ever done this before until I took my notes on this. But this is pretty crazy. So watch, I'm going to put absolute value, and then I'm going to put x minus 2, then I'm going to square that, and then I'm going to put a minus 3, and then I'm going to close the absolute value. So here, I'm going to put that down like that. So look at this. This is really crazy looking. All right? What if we didn't have the absolute value? It would look like this one right here, wouldn't it? Everybody see that? It would look like that. But what does the absolute value mean? It means we only use what? The positives. So look, you got some negatives here, don't you? Everybody looking? All right. So you've got some negatives here. If I stuck this, if I put this into here, what is that absolute value going to do with this stuff? It's going to make it positive. So what's that going to look like? This is going to go, like this goes down to 3 right here. You see that? Where do you think, what do you think it's going to do up here? It's going to go up to here and then come back down like that. So it takes that negative portion and it makes it positive. Okay, you see it? So let's click on this and see if it does. Boom, there it goes. So that, okay, is what that function looks like. Now, these aren't straight lines, are they? Still curved because it's a parabola. It still keeps going out and out and out while it goes up and up and up. Okay, it's not just a straight line. You understand what that absolute value did to that little piece down the bottom of it? It took all the stuff that was negative and it made it positive. Make sense? All right. So do you think you would be able to draw that on your own, like on paper? Well, again, what did it look like without the absolute value? You should be able to draw that on paper, shouldn't you? Yeah? Yeah, we just talked about it. You go over 2, go down 3, right? And then what do? Well, let's go by ones. Oh, let's go like this. There we go. Now we got ones. All right, so there's your 2, 3, 2, negative 3. And then how do you know what your curve looks like? Go over 1, up 1, go over 2, up 4, plot those points, boom, you got your nice curve, right? But now you could draw that parent function, sticking absolute value here. What does that do? It takes everything that was negative, right? Everything that was negative, what are you going to do to it? You're going to bring it up to what? Positive. So where is this point? This point right here is negative, or it's 2 what? 2, negative 3, if I could get it to show up. I'm going the wrong way. There it is. 2, negative 3. Do you see it? So now what do? If you can draw that parent function, you should be able to draw this in absolute value. So what do? Is I come up here and I put a point right there, right? Because it'll go to 2, positive 3 instead of 2, negative 3. And what about the other stuff? Where does it start going negative? It starts going negative right here. So I just draw a nice little curve up to here, and I draw a nice little curve down to there, right? So I'm not going to have anything below the x-axis. And if it's in absolute value, right? So there it is. So the curve looks exactly the same except for the stuff that's underneath the x-axis. So what you're going to have to do is you're going to have to be able to draw that by hand. All right? You could sit there and do a little X and Y table, put in a whole bunch of different points and see what it starts to look like. But I tell you what, that'll take you forever. Okay? It'll take you way too long. Okay? The best way to do it is, first of all, know what the parent function looks like. All right? Everybody watch this. See? There's your parent function. You know what that looks like, correct? Now, this one right here, what did we do to that parent function? All we did was move it to the right 2 places and move it down 3 places. Everybody got that part? That's the easy part. But this one says, okay, we're taking the absolute value of this thing. What does that mean? That means I can put in negative values, right? But what's my outcome always going to be? My outcome's always going to be what? It's going to be positive. So none of this stuff, all this stuff from here to here is not going to be in the negative range. What do? You just, boom, flip it up, right? So whatever the one, I don't know. Yeah, 1, negative 2. You see how 1, negative 2? Instead of 1, negative 2, what's it going to be? 1 what? 1, positive 2. That's right. So you put a point right there. Instead of 2, negative 3, what's it going to be? It's going to be 2, 3. You see it? And then what about 3? Instead of 3, negative 2, which would be right there, everybody see it? Where would it be? It'd be 3, 2 right there. And once you plot those few points, bam, there it is. See? Does that make sense? Let's make this a little smaller. Okay. There we go. Everybody see it? There's your 3, 2. There's your 1, 2. There's your 2, 3. All we did was take the negatives and we made them positive, and that flips that little bit up. And that's how we would graph something like that. So knowing those parent functions, what they look like, is actually very, very helpful. Let's do one more. This one's pretty crazy looking. This one's still absolute value, but we're not going to do absolute value of the whole thing. This is absolute value of x. All right, you know what that looks like, but what we're going to do is going to put a squared in here. Oops, I need a parentheses around this, parentheses around this, and then we're going to square it. Check this one out. Okay, this looks kind of like a W. All right, what's happening here? I tell you what, let's make this a parent. Let's make a parent function with this, just to kind of compare. And let's not put absolute value of x. Let's just see what it looks like without the absolute value. All right, so that's what that looks like. Okay, just x minus 2 in parentheses squared just means you do what? Just move it to the right 2 places, correct? And I'll tell you what, let's do this just to see. That's what I love about this program. It just makes it so easy to graph things. You can do it just to see what it looks like. And then let's put a squared. There we go. So that one, oh, because we're squaring everything in here. Yeah, I don't know if you could do this one on your own, but that's what that looks like. Do you see that? It actually gives you 2 things because you're squaring the x minus 2. So what could you do to figure out some of these points? Let's get rid of that one. Let's put in a 1. All right, and for this red one right here, put in a 1. What's the absolute value of 1? 1 minus 2 is negative 1. What's negative 1 squared? 1. So you got to point out 1, 1. Everybody with me on that? Let's put a 0 in for this. If I put a 0, 0 minus 2 is negative 2 squared is positive 4. So you got to point up right here. Okay? Again, look, you got a squared, so you know you're going to have a parabola shape to it. All right, so these are some of my key points. So I got a 1, 1, I got a 0, 4, and the other side's going to look identical. Negative 1, 1. What if I put a 2 in for this? Absolute value of 2. 2 minus 2 is 0, squared is 0. All right, put in a 3. 3 minus 2 is 1, squared is 1. Now you're starting to see it take shape. Does that make sense? So if you put a 0, you're at 4. Put a 1, you're at 1. Put a 2, you're at 0. Put a 3, you're at 1. And then it just keeps on going. Same thing if you put negatives. Look, if I put a negative in for the x, what does that do? It just changes it to a positive, right? So if I put a negative 1 in there, I still got a positive 1, just like when I put a 1 in there. See how they're mirror images of each other? All right, if I put a negative 2 in there, it's 2 minus 2 is 0, squared is 0. Put that in there. All right? It's crazy looking graph, but you can get these graphs fairly easily, okay? I know, it doesn't look that easy, but fairly easily if you just put some key points in there, all right? And you kind of know what it's going to look like. You got that squared thing on there, right? So you know it's going to go up as a parabola. But you got the absolute value, which means I could put negative numbers in here, and I can put positive numbers in here, and I'm going to get those same values every time I stick a negative number in for this. Would you agree? If I put a negative number in for x, I'm going to get the same value as if I would put a what? A positive number in for x. All right? So try that on your own. All right? You kind of know what to put in there. All right? So pretend you didn't even see the graph. All right? Where would you start? I'd start right in the middle. I'd start at 0, wouldn't you? So I'd stick a 0 in there. All right? And then see where it is. It's at 4. Put a 1 in there. Where is it? It's at 1. Put a 2 in there. What is it? It's at 0. Put a 3 in there. It's at 1. You're like, oh, okay. Well, it starts up here, and it's kind of going here, and it's kind of going here. Let's start putting some negative numbers in now. All right? So if I start putting some negative numbers in, you're going to see that this is going to look just like this. Make sense? You got to try it. You got to do it on your own. I know I didn't really draw it on here. I just used the computer program, but you got to try it. All right. And so try that on your own. All right. Just putting certain numbers in there, certain key numbers, and then you have a general idea of what it's going to look like. So then you should just be able to fill it all in. All right. You don't have to put in like every single point, and you can't. I mean, there's an infinite number of points to put in. All right. I know it's weird. I know it's crazy. I can tell by the looks on your faces that you're lost. But you gotta practice doing those. So the ones that we just did today, you want to try to do it on just regular paper. All right. If you have graph paper, that's way, way better. Okay. I would invest this weekend. I would go out to Rite Aid or Walmart or wherever you go. All right. Best Buy. Do they have graph paper at Best Buy? I don't know. Target, I don't know. Wherever you go to get stuff like that, get a pack of graph paper. That's what I would suggest that you do. All right, because it'll make it a lot easier for you if you're doing it on graph paper. Okay, if not, get a ruler. Oops, attached to this thing. Look, I keep a ruler with me. I keep a ruler in my computer bag when I take it home. I keep a ruler right here, and I mark them out. Okay, I don't just put random little dashes. All right, I make sure I measure it, right, and I put them all the same distance. Are you listening? So make sure you're accurate with this thing, okay? Gone are the days where you could just put a little line, just go wham, wham, and just put a little line like that, okay? It's not that easy anymore, okay? As you see, it's getting a lot more difficult, okay? All right, enough of that. Let's take a look at your homework. I'll shut this down, and let's just take a look at your homework and see what you're supposed to do with that.